Okay, guys, so 2.6 is everybody's favorite section. It's based on word problems, so I'll probably do about 2 word problems with you guys, and then if you have trouble in the homework, we can go over some of those as well. So first thing with word problems in general, if you're trying to build functions, you want to read the problem carefully and try to envision what is being described in the problem. So that'll kind of help you think what you're going to need. I would say normally draw a picture if possible and label what you know and what you need to find. I use variables in general when you don't know it and you need to find it. Write down ideas and formulas that may help. So again, if you're talking about a problem with a right triangle, you should be thinking, Pythagorean theorem, things like that, okay? If you're thinking about things with circles, you should be thinking of x squared plus y squared equals r squared or something. So use your formulas and variables to create a formula for the problem. So basically you have formulas, you have information, and now you want to create a new formula for this particular problem based on some of the information you've provided and based on the information given by the problem. So it says, another thing I've noticed is sometimes people get the right answer, but it doesn't fit in the problem. So always make sure that your answer or answers make sense with the problem. So I thought we could go over this one. This is kind of a classic one. I actually do this in my Calculus 1 class. In this class, we will need to use our calculator to help us with that. So just keep that in mind. But in calculus, I'll teach you how to do it by hand. So it says, let P be a point, let's call it x comma y, on the graph of y equals x squared minus 2. I would like you to express the distance d from P to the point 0, 1 as a function of x, okay? So what we're gonna do is we're gonna create, now we're gonna think, they asked for the distance. So that means we're gonna need how far something is. So a formula that I'm gonna need is the distance formula, which is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So that means we're going to have to find x sub 2 and x sub 1. So I would say the first thing we should do in this problem is we should draw the picture of it, okay? So I know that my parabola is x squared minus 2. I know that's a parabola that is shifted down 2, okay? So here's 1, here's 2, and then I'm going to draw it kind of upward like this, right? Something like that. That's decent. One of my better ones, actually. So now what I need to do is I now need to label a point. So they said there's a point 0, comma 1. So that would be right here. You know what? Let me do that in green. So that's the point 0, comma 1, right? Over 0, up 1. And then we have a point on the graph. Let's call it right here. No, you know what? Let's do it here. I don't know where I want to do it. What would make sense? Let's do it right there. So let's say that's the point on the graph, and they told us to call that point P, X, Y, right? So they said call point P, X, comma, Y. They said we have a point 0, 1, and now we want to know this distance right here. We want to know how far is that going to be? How could we calculate that? Okay, so the problem is, part of the problem is you don't actually know what X is, right? You don't actually know what X is. You don't actually know what Y is. You know this one point, but that's not the point for every single value on the graph. So we got to figure out a way to express this. So what I'm going to do is I'm going to say distance is equal to the square root. Okay, so we got our picture, we labeled what we knew, we put variables in. Now we have to create this new formula that they asked for. So x2 minus x1. Well, to me, it looks like x2 is that guy. So I'm going to say x, and then x1 is right here, right? It's going to be 0. So x minus 0 squared plus, now it says y2, so that's y, right here. There's y1 or y2 minus y1, but in this case, y1 is 1, and then we square it. Now, when we do this, we end up with x squared plus y squared minus 2y plus 1, okay? But they want it written as a function of x. Look right here, this is the key. They want it all written as a function of x. We have y's right here, so that's not acceptable. So what we need to do is we need to think of a way that we could get rid of y's. How could we possibly change y's over to x's? Well, if you noticed, what does it say right here? Doesn't it say right here back in the beginning of the problem that y is equal to x squared minus 2? So I'm going to come over here and I'm going to plug that in. It says that y is worth x squared minus 2. So this will become x squared minus 2 squared minus 2y plus, oops, we said x squared minus 2. I actually think it would have been better. Yeah, why don't I do this, you guys? Why don't I do this? Instead of foiling it out, why don't I replace this y right here with this guy over here? All right, why don't I do that instead of messing all this up? So let's do that. So this would be x squared plus, now this would be x squared minus 2 minus 1 squared, but that would be x squared plus x squared minus 3 squared. Now I can clean this up a little bit. This will be x squared plus x to the 4th minus 6x squared plus 9. If you FOIL this out, and again, guys, I'm just FOILing that out. So now we have distance is equal to x to the 4th minus 5x squared when I combine like terms plus 9. And now I have my distance formula to any point on the graph from 0, 1. Okay, so again, this is a formula that now would work for this particular point, and then the distance to any point on the graph of the red part of the parabola. So now they say, well, what would happen if the distance is equal to 3? I'm sorry, if x is equal to 3. So I just say d equals the square root of 3 to the 4th minus 5 times 3 squared plus 9. So that would be, what is that, 81 minus 45 plus 9. Geez, let me do my 90. Oh, that'd be 45. Right, and the square root of 45 is 3, let me see, 9 times 5, 3 squared roots of 5. So that would be our solution, 3 square roots of 5. And in general, you guys, I want the exact value. Don't give me the decimal unless it specifically asks for the decimal. So you have to know how to clean up the square root of 45. Hopefully you guys know that this is 9 times 5, and then 9 has the square root of 9 times the square root of 5, which is 3 square roots of 5. So that's how I did it, in case you were wondering. If that's something that you are a little rusty at, you may want to ask me during office hours to go over a few of those to kind of see. I have noticed a lot of students have trouble with radicals and simplifying and everything. So if that's something you're struggling with, definitely bring it to my attention and let's talk about it in office hours or, you know, whatever our meetings or anything like that. Okay. So now here's the hard part. It says, for what values of x is the distance the smallest? So basically saying what x value would you use that would get you the closest to 0, 1? So this is a calculus question, so we cannot actually answer this question with pre-calc. However, what we can do is we can use our calculator. So I'm going to take out my calculator. Takes a minute. Okay. So we have, let me make sure we have the right function. The function should be, let's see here, x to the 4th minus 5x squared plus 9. So we're going to do the square root, so second function square root, x to the 4th minus 5x squared plus 9, I hope. Minus 5x squared plus 9. Okay, so now I'm going to graph this. Okay, so that's the shape I get. Okay, so now what we're looking for is the smallest, the local mins. We're looking for the I guess the absolute mins, but they turn out to be local mins. So this is the graph of the distance formula. It is not a graph of the original parabola. This is the graph of the distance formula. So we're going to use this feature on our calculator that says math. Okay, and then we're going to find the min. So I'm going to go F minimum. Oops, graph. Let me see here. Oops, I think it's this one. From the graph we do calculate. I'm sorry about that, guys. So let me take you back. So we're on the graph screen. Now we go to second function calculate. It's right there on trace. Okay, and we go to minimum and hit enter. Now we're going to tell it a little to the left. So right about there, and we're going to hit enter. and then it's going to say a little to the right there. So now it's going to say, do you want me to guess what the minimum is in between those two values? I say yes. So it says the minimum is approximately negative 1.58 comma 1.658. So they say, what values of x is d the smallest? X equals negative 1.58, if we round off. Okay, so in this case, you can't do it without the calculator, so you have to round. However, I bet you we're going to get the same exact value, because isn't there another local min? So now we're going to do second calculate. We're going to do another min, and we're going to do this one. But I'm pretty sure it's going to be positive 1.58. So there's my left bound. There's my right bound. And what you're telling the calculator is find the value in between those two values that's the smallest. So we say guess, and it's 1.58. Very good. So we say, and x equals approximately 1.58. So these would be the two values that would minimize the distance on the graph. So this is an important problem for Calc 1. Right now, we're just kind of learning it. We're just kind of talking about it. It's not too crazy, but it is something you want to understand. Now, I'm going to give you guys another one, and we're going to say a rectangle has one corner. So this isn't the one, this is the one from your book. I actually use a different one in my calc class, but we'll try to work with this one. A rectangle has one corner in quadrant 1 on the graph of y equals 16 minus x squared. Okay. Another at the origin, a third at, on the positive, y-axis. Okay, so this one's going to be kind of tricky to draw. We're going to have to do this one. So, and the fourth on the positive x-axis. Okay, so I'm going to try to draw this real quick. So they're saying there's a rectangle with one corner in quadrant 1 on the graph of 16 minus x squared. So let's draw 16 minus x squared. So 16 minus x squared is really a parabola that is facing downward, and it's up 16. So let's say that this is a height of 16 and it's a downward facing parabola. Okay, that was horrible. Okay, so we have this downward facing parabola. Okay, and it says that in one corner of our rectangle is on the graph. So right here, let's say. Another corner is at the origin, so right there. A third is on the positive y-axis, and a fourth is on the positive x-axis. So they kind of forced us to draw it this way. That's the only way it would be a rectangle and not something else, okay? So now they ask us, express the area A of the rectangle as a function of x. So we want to know how we could create an area formula for that rectangle that's inside that parabola as a function of x and x alone. Okay, so I'm not 100% sure how to do this one. This one's a little bit different than what I do, so we're going to have to work through it. Well, let's see here. I know that area is worth length times width or base times height, however you would talk for a rectangle. Okay, so in this case, maybe if I name this point right here, x comma y, maybe that'll help me. All right, so this is this point right there on the parabola y equals 16 minus x squared. Well, let's see here. We're not doing distance, so we don't want to use our distance formula like last time. Is there a way that we could talk about the length and the width? Well, don't we know that this length right here would be a length of y? And don't we know that this distance here or this distance here would be a length of x? That's a length of x, and this is a length of y. And again, why do we know that? Because this point right here on the corner, right there on the parabola, if that has a coordinate of xy, so wherever it's at, we don't actually know where it's at, but wherever it's at, it is going to force this rectangle to have a height of y and a, or I should say a base of x and a height of y, or a length of x and a width of y, whatever you want to call it. So I'm going to try to rewrite this now. So now I'm going to say that it has area, which is x times y, right? However, they want it written only in terms of x. Well, that's okay. We're going to use similar thinking to last time. Right here it says that y is worth 16 minus x squared. So I'm going to say x times 16 minus x squared. Remember, this is my y right there, so that worked. So now if I clean this up, this becomes negative x cubed plus 16x. So that is my formula for the area of this rectangle. Not so bad, right? Now they ask us to graph a of x equals negative x cubed plus 16x. So I'm going to take out my calculator and I'm going to graph this on there. So let's clear. Let's go to graph. Oops, y equals, let's clear that. And we have negative x cubed plus 16x. So negative x cubed plus 16x. So let's graph this guy. Okay, so I'm going to do zoom fit. Whenever you guys are struggling to get it to fit, zoom fit is a good way to get it to go into the window that you want. Ooh, that kind of doesn't look like I want. Let's zoom out a little bit. Okay, so we have something like that. So when they ask me to graph it, I now have this graph. Oh. Negative x cubed plus 16x. Okay, that is definitely not the right graph. Okay, so I'm going to try this now. And this should be what it looks like now. All right, something like that. Okay. And then it says for what values are the areas the largest? Okay, so, well, the problem is, no, actually that I need calculus for that. Okay, so we graphed it, and I just feel like this graph, I'm doing something wrong on my calculator. Let me go back. It's negative x cubed plus 16x. So let's go to window. So let's do negative 100, 100, negative 50, 50, oops. Okay, there we go. We're starting to get something that looks a little bit better. So let's go to Zoom box. Well, you guys, I'm having a little bit of difficulty with the calculator on this one. I might have to call it and then talk to you guys about it in the meeting. Yeah, I don't know why this is. So, yeah, window. Let's see if that's the mistake. Okay, there we go. That's more like it. Okay, so now we're getting a graph that looks a little bit better. Something like that. Does that look close? Kind of. So then what I'm going to do is I'm going to try to find the maximum value in this problem. What value would maximize it? I don't know if this will work. I'm already having enough trouble with it, but let's give it a shot. So now I'm going to go to second calc. I'm going to go to maximum, because now we want to see what value would give us the largest area. So I'm going to go, yeah, I think second quit clear. If you guys ever struggle with your calculator, try what I'm trying. Oops. I'm going to go into second memory and I'm going to reset. Okay, and I'm going to go to defaults, reset, enter. So it should be done. Okay. So now let's try that again. Let's graph it. Negative x cubed plus 16x. Oh my gosh, this is the worst right now. I'm sorry about this, you guys. This online calculator is just messing me up right now. X cubed plus 16x. Let's try to graph it. I don't think that's right. Nope. Nope. Yeah, I'm definitely going to have to mess with this a little bit, guys. I'm sorry about that. So I can't get it to work quite how I want. My other calculator completely froze. I have to remove the battery. So everything just kind of went wrong on this one. So we're going to take a look at this off screen, and I'll try to mess with this a little bit. But you guys could graph it, and then we could use our calculator to find this value or this value, whatever is needed for the particular problem. I'll try to mess with the calculator and see what's going on with it. All right, you guys, I'm going to end the video and go work on this. All right. Thanks for watching. Sorry about that.